All right. First of all, thanks for having us talk about the Inference service. Very excited to present what we have done so far. Big credit to Christine for providing all of the workflow tools, and that make our presentation a bit easier to digest because Christine covered very well the Globus compute part, which is underlying the underlying service that we use to run our Inference service. Okay, we will talk a lot about large language models, and I just wanted to say upfront that our future vision is to also be able to serve diverse type of model, like AI models and foundation models. But today we will just focus on large language models since that's what we have. And yeah, big credit to Aditya. He's been pouring a bunch of time with me to build this service, and now we have a lot of collaborators that help us manage the system, make sure that the HPC resources are working. A lot of Globus folks that helped us with a lot of things regarding to authentication, using their services, etc. So I just want to say a big thanks. And even if I'm going to speak a lot in Aditya too, there is more people behind. All right. So ALCF, there is a bunch of AI cluster that are currently being deployed. We have Sophia that have a 100 GPUs, and that's the cluster that we are currently using to deploy our service. We have been using Polaris in the past for the early stage of development, but there are upcoming cluster that are only going to be exclusively going to be dedicated to AI and inference. So there's NVIDIA, Sambanova, Cerebras, etc. So what we're trying to do is to capitalize on all of these amazing cluster coming and be able to use them to serve more inference models. And our ultimate goal is to provide inference capabilities to a lot of scientific communities and be able to hide all of the complexity behind the scenes, such that you don't need to have an account at the ALCF. You don't need to have access to Cerebras, for example, and know exactly how to work it out. It's just here are the easy point of entry and go to town, if I can say. And one of the easiest point of entry is a web interface. So Aditya is going to cover more like how to interface with the service, but I still wanted to give a little overview. And this works pretty much like a ChatGPT in a way. You log into our web interface. There is a bunch of models that are available, and then you just type your question. It gonna spits out an answer. We have streaming enabled, and you can keep conversing with the models. It does format pretty well tables. Some of the models format the equations pretty well too. There's code formatting, so we're continuously working to provide a better experience when you interface with our service in that matter. And then the next point of entry that we provide is an API, which is OpenAI compliant. And that's probably the point of entry that you would like to use if you want to programmatically interface with our service. For example, if you want to blast the system, multi-thread your application and send many requests, or if you want to integrate the inference API within your own workflow that could run on Aurora or elsewhere. So that's probably the route you're going to want to take. And it's again, Aditya is going to cover this in more detail, but just to give you a heads up, as long as you have an access token through Globus, which I will demonstrate later, that's really all you have to need to be able to interface with our service. You can do curl, you can do a Python request, and what you would get from it is a bit more raw. The output is not as nicely processed like the web interface, but you do have all the information. You have some statistics in terms of how much compute time it took, how many tokens you generated, what's the throughput, etc. So this is the kind of interface we want to provide to the scientific community, and in the background, it's all running within our ALCF resources. I see that there may be some questions, so I'm not going to keep track of it, but feel free to interject, Ricardo, if you think I should answer a question. I'm happy to be interrupted, basically.
Sounds good. Thanks. I'll keep an eye on the chat.
Sounds good. Thanks. Okay, so that was just the introduction. Next, I will go through the architecture overview, just explain to you how the service all works. And it may or may not be useful if you just want to use a service and not bother how it runs, which is kind of our goal. You may want to go grab a coffee or something, but I think if you're still interested, I will stick around for sure. Then capabilities and feature, I'm just going to explain, given our architecture, what are the things that are enabled by that. And Aditya is going to conclude by giving some usage, an example a bit more concretely, like all the different things you can do with our service. A lot of what we're going to present today is already in our documentation. There should be the link should be there as well in our GitHub repository for the workshop. So a lot of the instruction on how to access it, get your access token, and do some example with our URL. It should also be in that documentation right here. All right, so let's get started. So this is a very simplified view of how it all works. I'm gonna come back to Globus Auth in a little bit, but usually you have yourself, the user, who will first use our auth script to be able to get a Globus access token. So this effectively is going to become your API key that will give you access to the large language models. Then you send a request to our API, which is currently on a virtual machine. And if you also use the web interface, which is our web UI interface, you don't need to get a token for yourself. The web page is going to take care of this, and the web interface is going to send a request to our API on your behalf. So this is always the formal point of entry to access our service. Now within this, there will be a bunch of things that happen. We validate who the user is. For now, given the current policies, we only allow a user who authenticated with their Argon or ALCF credentials, but we are working toward expanding this and allowing more institutions to access our service. So if you want to try it today, that would be the constraint. But otherwise, you can access the API and the web UI from anywhere from an internet connection. Okay. After that, if the request makes sense, the user is authorized, then we go through Globus Compute, which is something that Christine has explained in her talk. And that is our way to trigger remote computation on different systems. So for now, we have our API that is in isolation. It's not tied to a specific machine, and that allows us to be able to offload the computation to any cluster that we want. So for now, we are running on Sophia, but once we have other cluster coming, if we keep going with Globus Compute, we're going to deploy the endpoint on all of these machines, or we might even have like a special API access from our virtual machine. But for the integration with the HPC system like Sophia, we are using Globus Compute because it has all of these nice tools to naturally schedule job through the scheduler, etc. So none of this is viewed by the user, but what's happening behind the scene, if you're targeting one of our large language model, it will target a specific endpoint that hosts this model and run the inference for you. One thing to note is that we have a combination of in-memory slash active models and also on-demand models. So that means that we have some nodes that are reserved to us on Sophia, and we have some large language models that are persistently served. So if you want to target these models, you will not trigger a job at all. It will already be running, so it will act pretty much like a persistent service. It will be rerouted directly in the compute node. But for other models that are on demand, that means that we cover a wide range of models, and some of them are not always active. But if you want to use them, you can still do so by querying the model, and that will automatically submit a job through the scheduler, acquire the compute node, and start the model for you, and you can use it for up to 24 hours. If resource permits, of course. Okay, so from the user perspective, Globus Auth is pretty important. We're all integrated with Globus, so that is the point of entry. And Globus Auth is OAuth 2 OpenID compliant. It's a federated identity provider, which is pretty great. You can a lot of institutions are included with Globus Auth. For example, Argonne, there's universities or different labs, and you choose the one that you have. Currently, as I said, it needs to be Argonne or ALCF, and then it will redirect you to the authentication page of your institution. and that's how you're gonna basically get your access token through this. And as I mentioned, for example, this is an example with the OpenAI package. If you're used to it, there's the API key where you will basically swap that for your Globus access token, and that would be understood on our API level, and we will be able to figure out if you're authorized or not. Hopefully you will. I see a lot of chat, so hopefully it's not a question that I'm missing, but I'll keep going until someone interrupt me. Or actually, is there any question at this point that
Yeah,
people would
maybe
like to?
I can ask it right away since you paused. Can people with Argon collaborator accounts use the inference service?
Argon collaborator account, I would say as long as you have a credential to authenticate with Argon in like if you recognize like that screen right here, yes, I think you should be all good to go. Like for example, ALCF, you don't need to be a staff as long as you have ALCF credentials. Like for example, if you're a user of Aurora that and you have been given ALCF credentials with your mobile pass token, you will be able to use our service. Like you don't need necessarily to be a staff for ALCF. So for ANL, I'm not exactly sure what an ANL collaboration account is, but I guess I would give it a try, and that would probably give the answer.
Yeah, I guess want to point out with respect to your answer that most of our attendees who have requested to access our machines, then they have a username and mobile token, so they should be able to access it. And if they don't, I would
Yes.
suggest them to ask us in the Slack so we can help them out.
Yeah, exactly. Yes.
Okay.
Yeah, if you have your mobile token and the LCF account, that should be all good.
Thanks, Aditya. I think that's all the questions for now.
All right, sounds
Oh,
good.
sorry, Benoit.
Okay. All right. So Globus Compute, I'm just gonna stay brief, but as Christine mentioned, so this is something that can trigger analysis from anywhere with an internet connection. The only two piece that you need really is the endpoint, which is going to be deployed where you want the analysis to run, which is in our case a Sophia login node. And you need to register function, which is going to tell Globus Compute what is the task to be run on those nodes. And usually Globus Compute is like for everybody to use, but in terms of our service, we are not exposing any of the endpoint and any of the functions. So basically the admin of the project are deploying all of this, and we keep the endpoint ID and the function ID to ourselves. We make sure that only these function can run, which is the inference function. And the user just need to query our API or the web UI, and behind the scene, we're going to use endpoints and function to execute the task on your behalf remotely on those machines. Okay, so one of the key aspect of our service is the endpoint deployment. That's where most of the magic occurs. So how it works is, for example, here we are in the Sophia space. We have admins, me and Aditya, effectively at this point, and we can SSH in Sophia on the login node, and we have special sudo rules that allows us to become a service account. And the service account is just tied to a particular service, in our case, the inference service. And any analysis that will run under the service account will be tied to the particular service. So basically, the inference service runs are not tied to me or Aditya. They are already tied to this abstract account. So once we are in this service account, that we deploy endpoints, like what Christine mentioned, and from that moment, if people trigger a request to inference on our API, it will go through Globus Compute, through our endpoint, and run as a service account. And we make sure that basically that is the route that has to be taken, just to make sure that we can properly log all the activity and make sure that what's requested is available. And then the important part is what happened when the compute endpoint spins up a job through the scheduler. So there's two phases. First of all, if the job is not running, it will just send a PBS job. And once the nodes are acquired, it will load the targeted large language model into memory. And that's very important because we have different endpoints, and that needs to be set ahead of time. So each of our endpoints are actually loading different large language model. The second step is to start a VLLM server. This is the inference framework that we use to serve the inference from within the compute node. And then the node is going to keep hot. Now for persistently served model, basically we have virtually like an infinite wall time or until the node crash or there's a maintenance, one of the above. And but for the nodes that are more on demand, it will keep it hot for between 2 hours and 24 hours, depending on how heavy the usage is. And once the node is up and running, we call it the cold start. Any subsequent request is just going to be funneled through the endpoint, through the compute node, and we will poke the VLLM server and give back the answer all through Globus Compute. So basically, once the model is loaded, there is a minimal wait time. Okay, in terms of models, that's probably starting to be more relevant if you want to use a service. We have 30 for now, I think a bit more, and the list is continuously growing. And if you want any of your model to be served to help your scientific application, please send a message to ALCF support, and we'll be happy to add the models for you, and so you can actually use it. So we have a Qwen, we have OpenAI, some Google model, we have some Aura GPT in-house models as well. And yes, so all of these, subset of them are persistently served, and some of them are on demand. But we are always happy to reshuffle which one is persistent based on what the user needs. Okay, now I'm going to quickly go through capabilities and feature, and then leave the stage for Aditya. So I touched this a little bit already, but we have dedicated computer resource. And when we think about HPC system, maybe a lot of us are thinking about waiting in the queue. And for a long time during the early deployment of our service, we did not have dedicated resource, so we just had to compete in the queue, which is nice. That's the natural way of things. But we had days where the machine was full, of course, and no user were able to send any inference request. But now that this project is gaining some momentum, we do have dedicated nodes, so we can totally bypass the HPC queue and the cold start for these models. We can auto scale. So this is something with Globus Compute during the configuration that you can set how many nodes are you allowed to acquire. So if, for example, here, this is serving a particular VLLM model, let's say an Emotron model, and there is too many people using it, then Globus Compute will understand that and will naturally submit another job to acquire an additional node with the same model to be able to accommodate more traffic. Then, because of our disconnected architecture, where you have the API, which is in a separate space than the actual compute resource, we do everything remotely. And that brings interesting opportunities like having some backup in case there is some maintenance. If we have models, the same models serve on cluster C and cluster B, but the B is under maintenance, we will be able to naturally reroute to another cluster without the user knowing it. And also, if different clusters are specialized to different models, but then we have other clusters that are specialized in other type of models, we can still serve all of them through the same interface and optimize and increase the amount of models that can be served. Okay, this is more for the admin of the project, but we do have monitoring capabilities. We know who is using it, where the point of failure, how many requests has been processed. And so far, we have processed over 8 million requests, which total over 10 billion tokens. And this is just a bit outdated histogram, but this was at the time where we had a histogram. This is all the models on the x-axis, and this is the number of user on the y-axis that has used this model. So this is something that shows that almost all of the models are a bit used by the user, and that's something that our service has. That's one of the strengths of our service, that we are allowed to serve quite a lot of large language models for that can be used for different scientific cases. Okay, and then this is more for the future, but we have container capabilities. Like we technically started to containerize all of our applications. And what we are planning to do with other ALCF staff in the operation team is to move our API and our to a Kubernetes cluster, so that will allow us to process even more requests and scale our database and scale our API resources accordingly, should the service become in very high demand. All right, so that's the moment where I will give the floor to Aditya, but if there's any question before I do so, I'll be happy to take some questions.
Thanks, Benoit. There's nothing in the chat, but if people want to unmute or ask right now, then maybe we can pause for a few seconds.
All right, yes, people are eager to see the comment lines. I'll stop sharing.
Sounds good. Thank you.
I hope Aditya is here, by the way. I don't know. I didn't check. Maybe.
Aditya, are you?
Yep, I'm here.
Okay.
Sorry. Can you see my screen?
Yeah, the one with the aurora in the background, or the slides. Yeah.
Yep, the slides. Okay.
Yeah.
Well, thanks,
Awesome.
Aditya.
Yep. Thanks, Benoit. Yeah, I was just trying to figure out where the unmute is, so that took me a little while. But anyway, great. So I will take over the usage part and try and walk through some examples on how to use our endpoints, either by interfacing it through an API or by interfacing it through a user interface. So I'll begin with the API and then I'll move on to the web interface part. First things first is so the we obviously, as Benoit mentioned, would need an authentication token to interact with the API, and for that purpose, we have a nifty Python code which will generate a token for you, and then you can just copy that token and use it when you want to make those API calls. So all the usage examples are actually already also made available on our documentation. So either you can feel free to try them out uh, uh, at your own time or as we keep going along. So once you get that the Python code which will generate that token for you, you can run it on any machine, and then it will generate a token, and then you go through a couple of steps where you need to authenticate by selecting your identity provider. In our case, it could be an ALCF account or an Argon account. And then once you go through that, you will get a token, and then you basically follow a couple of steps, and then you'll be able to generate a token for yourself. Once that's done, we have a couple of endpoints, if I can call them that, where which here when I'm using the word endpoints, I mean to say just API calls that you'll make to our service to provide more information. But the first endpoint which I probably will try and speak about is the jobs endpoint. So what the jobs endpoint lets the user know is that we as Benoit mentioned, we serve out a large number of models, and we plan on serving out these models on various clusters. So if you want to get a sense of what models are currently running hot, models that are currently queued, where exactly are they running, and so on and so forth, you can use the jobs endpoint, and that will provide you a JSON output file or a JSON output code that then you can parse to see, the exactly that, like which models are running, which are queued, and so on and so forth. So this is just a truncated version of that, but if you run it yourself, you'll be able to see all the models that are currently being served out on Sophia. Next, one other endpoint which we make available is the list endpoints. So list endpoints is mainly to tell all the available models that's being made available by our service. So a combination of list and jobs will more or less tell you where the endpoint is at, or where the model is at. Like, is it in a running state? Is it queued? Is it like currently active, and can you use it or not use it, and so on. And list endpoints also provides you what are the ways to interact with that model. So there's several modes to interact with a model. Like there's chat. There is if you there's an embedding endpoint as well, and then there is for vision capabilities there's /image. So you can different models have different capabilities, and based on the capability of that model, you can target the appropriate endpoint and get the appropriate result. So all of our API endpoints are designed around the OpenAI API. Uh, OpenAI API has lately been the standard protocol to interact with large language models, and there's several packages which integrate well with OpenAI API, and hence, we designed our backend API to mimic it. That being said, we can obviously relax it if and when needed. If some of the models don't really follow the OpenAI API, we can afford to relax it and make them available as well. So the first example I'm going through is the chat completions endpoint, and there are several ways to use this API. I will show you through the command line, which is like through curl. And of course, there are other ways, like you can use Python and you can use the OpenAI API package itself. But if I have to walk through step by step, then yeah. So in the curl example, you will generate after you generate that token, you can then choose in your request payload, select which model you want to run it against, and the messages is the keyword which is what the model will see in order for it to respond. So by that I mean to say, here we are asking the Meta Llama 3.18b model explain quantum computing, and then the model will respond in a JSONized format with what it thinks quantum computing is all about based on how it has been trained. So different models have different capabilities, and some models, perform better with some queries than others. And yeah, there are several benchmarks out in the open where you can obviously see and decide on which model serves best for your use case. The same thing can also be done using the request library in Python. Um, Again, you generate the access token, pass that token, set the payload, and then use request.post to pretty much do the same thing, but within Python. And then there's a third way to do this, to interact with our endpoints, which is using the OpenAI SDK. For this, you would need to install the OpenAI package within your environment. One other thing which I perhaps missed mentioning is that when you want to generate your token, you need to have Globus SDK installed in your Python environment as well. That is a prerequisite. So the prerequisite of having Python, having Globus SDK is a hard prerequisite, but we are going to work out ways to relax it, and basically a user can then generate token without having them as well. But that's still in the pipeline though. So yeah, this piece of code is mainly telling you the same thing. You're using the chat completion endpoint for the same model and asking a query using the OpenAI package in this case. As I already mentioned, there are several kinds of models that we are serving out right now. There's the chat completion, then there are some vision capable models. And in case you want to interact with the vision capable model, you would get the image and load it into memory in the base 64 encoded format. and then you would pass that base64 encoded image format to the model. And based on that, you will see appropriate responses for that image. So you can ask within your workflow, if you want to generate text for images, you can afford to use this endpoint as such, where you pass the image and then you get some text response for that image. Then we also support embeddings endpoint. Embeddings are like numerical representations of text. More often than not, embeddings are used for retrieval augmented generation. By that, I mean, if the model is not trained on a set or on a specific data set, you can afford to provide the model some context during runtime. And the way you provide context, one way, I should say there are several ways, but one of the ways to provide context is to generate these embedding vectors for your text and then load them into a database. And then the model within its workflow will look through these embedding vectors, do some similarity search, and then provide relevant information to your query. So if you want to ask something related to your domain of science, for which the model has not been trained, you can generate a RAG-based workflow which will look at this database and then generate results by using that as context. More often than not, that's when the embedding models are used, but I'm sure there are several other use cases for embeddings. Then, so we have users who are also using the models by defining tools, and then some of the models are very good with tool calling. So a user can define an own tool, and then you can ask the model to retrieve results by calling that tool. Let me see if I can show you an example of, since we have time, I'll probably spend some time in showing you a tool which one of our users has used. Can you see my Python notebook?
Yes.
Perfect. So what I'm trying to show is how you can use the inference endpoints to enable tool calling, right? Like, for example, more often than not, like the couple of packages which users use is LangChain and LangGraph to enable tool calling. And then here's an example where you're defining a tool called getWeather, and then you're asking the model, like, what is the weather in SF? And the tool knows that if the query happens to have like the word SF in it, it can return a particular result. Uh, this is a very naive example, but you can figure out, like, you can think of ways that this would be useful, where you're uh, having the model call external tools and making it run codes and then generating results back to the user. So in similar vein, there's a tool PubChemPy which has been built out and which is actually being made available to users, where a user has now enabled a tool where if you give the molecule name, it will run it against the PubChemPy package, and it will give a smiles format string for that molecule. So in this case, if an end user is asking, okay, what is the smile string for carbon dioxide, then uh, this application can call the tool called molecule name to smiles, and then and then call PubChemPy package itself, and then give the smiles format string for that molecule name. And using LangGraph, you can actually, call multiple tools and make them interact with each other. And there's several literature out there where people have used several, used a lot of tools and made them talk to each other and generate and run codes on the cluster itself. As a matter of fact, I think the next talk probably will, actually go into something similar in much more detail. So that is about tool calling, and let's see. So apart from that, we also have batch processing enabled. Uh, in if your use case is such that you need to process a large number of requests, and you do not, and so right now our endpoints are rate limited, and also they are shared across several users. So you may see some latency if there are multiple users accessing the same model at the same time. And also, like, if someone's like running a for loop on their requests and hitting our model several times. Currently, we do not have the infrastructure, or rather the number, we do not have enough resources to scale up as much as we want. Like we do not have the resources like the OpenAIs of the world or the Anthropics of the world. But if you have a use case where you want to run through uh, about several thousands of requests, or like LLM requests, and you want that model to be dedicated just for your use case, you can use the batch endpoint for which we've made available. For the batch endpoint, what we ask the user to do is have an input file and send it over to us. So the input file can look something similar to this, where you have what is you specify what the URL or what endpoint you want to hit, what the model should be, and what is the prompt that you want to run the model against. So you said that you can create about 100,000 or 200,000 number of model requests in an input file, and then you pass that uh, file to our application. What this would do in the backend is that it would start a globus. It would pass that input file to our the 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 Globus compute would basically transfer that file, or you take that file, run it against that model, or start up that model and run it against that model, and then as output it would generate another file which you can then parse through to see the results. So to that end, we have several endpoints. One will be actually sending over that file or passing the file to the model. And then you can check the status of where the job is. Given the fact that, the cluster may be backed up because there's several jobs that are running, you can see if the job has run and if it's completed or not, and you can query it using this endpoint. And then you can retrieve the results based on the batch ID through the /result endpoint, and then you will be able to see the output file with all the results for that input batch. So that is the API-based access for our service. Before I go to the UI part, does anyone have any questions? I take that as a no, and I will move on to the interactive chat UI part. So we currently use a tool or an open source application called Open Web UI. It provides a chat interface to interact with our API, and Let me log in. So once I'm able to log in from my username, I'll be, we, if you scroll, if you click on the drop down on at the top, you will see the models that are being currently served live. The starting tab tells you which models are currently about to start and go to live. Queued will show you what are the models that are currently queued on the at the back end, which is Sophia in this case. And offline models are basically all the models that we currently are made available, but they're currently not served. So if a user say wants to try out a new model, they can pick any model. It will tell you that it's offline, and if you query it, it will then change. It will try and queue up that job based on how backed up the system is, and make it available to the user. But in the meantime, while this is being queued, we can try out a different model, and let's say you want to, try out the OpenAI GPT OSS 20B model, uh, asking it a preset question that we've made available. Since the model is already hot, it will just pass on that query and then, generate the results for you. Um, some cool features when it comes to OpenWeb UI is that you can do a comparison of several models at the same time. If you want to, like, say, pick 3 models, ask it the same question, then it would pass that question on to different models, and you can make a comparative analysis of, like, how each model, although provides the same output, does it differently, and pick the model which serves best for your purpose. And of course, OpenWeb UI also provides chat history of all the chats that you had going, and that is about the web UI. I'll just go to my slides and see if there's anything else that I want to cover. Yep, based on web UI, it preserves chat history, compares models. So some use cases that we currently have. So the folks who have already built a system called Ask ALCF. It uses a combination of the endpoints that we are currently serving plus a RAG database, which has a history of all the support tickets that we have had in our database. And basically, when you ask a query to Ask ALCF, it will see in a historical context, if someone's asked similar question, it will basically a chat bot for ALCF. So it's currently not yet public, but we are working towards it. So that's one use case of using inference endpoints to build chatbots. There are other use cases like ChemGraph, which I just showed you, where a tool calling based use case where you ask you know uh, uh, give the smile string format for a molecule and so on and so forth, and it will call appropriate packages and then generate results back to the user. And then there's the Aurora GPT project themselves, who are also using the inference endpoints uh, to generate large amount of data, which they can then train newer models on. So synthetic data generation is one other use case as well. So there's several use cases, and we are trying to collaborate with different science users, and also expose and also make this available to more users in the near future. And so that concludes this part of the presentation. I guess I have 12 more minutes, but uh, we can use this time to answer any questions if anyone has any.